Hello, today we're going to be learning on what is a derivative and how do we derive any function or constant. If you watched my other video on the limit definitions and what is the limit, you can actually use that along with this and it will help you understand it a lot more because I understood the limit definition a lot more. A derivative is the slope of the tangent line at any function at a specifically given point. We can see that graphically on here. Say we have the function f of x is equal to x squared. That is what x squared looks like. And say right here, that's our tangent line. And we want to know what is the slope, m. If you did college algebra and pre-calculus, you'll always know it as m. Now, in calculus, you'll be knowing it as f prime of x. But what we mean by f prime is we are deriving the original equation to see what that point is. You can do that using the limit definition, which will help you learn how to derive things. So, just like the other video, like I had showed, the limit definition of the derivative, f prime x is equal to, as the limit h approaches 0, f x plus h in parentheses minus f of x all divided by h. You can use these in different forms, many different forms. One of the most easiest to realize and the easiest to memorize would really be a constant going through this whole function, because the derivative of any constant, which is just a number, 5, 4, 6, whatever, it's just a number. The derivative, or otherwise the prime of any number, is 0. And this proves it. That is what the whole point of the limit definition is. You are proving what it equals to when you take the prime. So we have fx equals to c equals a constant going through the motions of the limit definition. So f prime of x equals the limit as h approaches 0. You plug in where you had your x. You see here, you plug in your c. And h approaches 0 means h is 0. So you put a 0 right there. We're not going to get rid of that just yet because that's going to be confusing in the beginning, so you want to hold off on that just for a second. C minus c is just 0, so here we have the limit as h approaches 0, 0 over h. Now we're going to go ahead and plug in that 0, and the f prime of that x is just 0. That's the problem of a constant, a number. That proves physically that any number, when it's derived, it is equal to 0. Here's a little bit more of a complicated one when we don't just have a constant, we actually have some variables involved. We're going to go ahead and plug that in, but hold on now, we can't just plug it in. See, that's a variables, that's a whole function. We can't just plug that in for where x is. So what we're actually going to do is we're going to take this, plug it in, and use the FOIL method to find out exactly what is fx plus h. Because you see back up here, fx plus h, we really want to figure out what it is. So we're going to go ahead and FOIL it out and then add it to there, and then it's going to come out as x squared plus 2xh plus h squared plus x plus h. If you took in college algebra and pre-cal, you know what the FOIL method is. So you should know how to do that. Okay, so then once we found out what x plus h, f of x plus h equals, we're going to go ahead and plug it in. Okay, then we're going to subtract and combine all of our like terms. You should know how to do that. Okay, then you're going to have this. Here, we can actually factor out an h, like we did right here. And then, once you get here, this is a great opportunity right here to go ahead and plug in 0 for all the h's. And then when you do that, it gets rid of all the h's, and then you're just left with f prime of x is just equal to 2x plus 1. This is the hard way of figuring out what your derivative is, but once you get further along, you'll learn the rules of taking derivatives.
And that makes things so much easier. So much easier. Like I told you earlier, any constant primed will always equal 0. Always. Say if you have a constant times a function, like 3 times x squared, it will always be the c times your function. And there, if you have an exponent, like I said, x squared, and you're taking the prime of it, you'll actually pull down the exponent, so it would be 2x and then minus 1, so then you're not left with an exponent anymore. That's called the power rule right here. It's a very commonly one used. Exponential, e to the x, when you take the derivative of it, will always be e to the x. It's very complicated to put it in limit definition and do all that yahoo, but if you always remember, e to the x is always e to the x. That's your exponential rule. Say you're adding or subtracting 2 functions, f and g. Okay? When you're taking the derivative of that set, you f derivative, plus or minus, depending on what your equation is, g prime. This is called the sum and difference rule. Okay, say you have 2 functions that are being multiplied together. Then when you're going to use what's called the product rule, you're actually going to take f prime times g, no prime, you're just taking the normal g, plus f, normal f, g prime. That's called the product rule. And then here, if you have a rational function, which is just a function divided by a function, you're taking the prime of that, you will take low d high g f prime minus f g prime all over g squared. This is known as the quotient rule. These rules and these limit definitions really help you out in calculus, and I would very highly recommend you study.